So this week I'm gonna be doing a dopamine detox, which means that I won't have any entertainment or music or anything that releases too much dopamine. I think I will still watch videos about programming. So I will watch these videos here and other videos related to programming, but I won't be doing or seeing any entertainment or anything related to that. And that probably means that it's going to be very painful and I'm gonna be very low energy because leading up to this week, I've drank a lot of energy drinks and coffee just so I was prepared to. I kind of wanted to exhaust that, so I was prepared to do the dopamine thing. So that probably means that I will be streaming a lot as well because I'll probably get really bored, which is the point and the reason why I'm doing this in the first place. Is to start the year on the right foot. So I think here I'm gonna keep working on this tool here that I was working on. Which is the graph to the script to visualize the other scripts that I choose. Oh, this is actually huge. I didn't realize this file was so big the first time I opened. Notification. So it creates the whole graph with style, with CSS. Hmm. Parsing and collecting nodes and edges from the Python. So these are from the data frame I created for the script. So I can probably change the way that the graph looks by changing these parameters here. I want to see it if there is a way to do it on the Python first. I wonder if there is a plugin for live server on Pycharm, just like there is for VS Code. Yeah.
Pycharm Professional, the plugin for live edit. Now, when I right-click and create a debug configuration, a private Chrome session is launched, and as I edit and save, I see the updates, HTML and CSS. First, make sure you install into Pycharm Professional the plugin for live edit.
Maybe it's this one it's talking about. Live edit should at least rerun the debugger. Yeah, I think this is probably the extension it's talking about. The plugin.
Now, when I right-click and create a debug configuration, a private Chrome session is launched, and as I edit and save, I see the updates. This no longer needs a special extension installed in Chrome. It uses the Chrome DevTools protocol.
Hi everybody, this is David from Newton Girls Who Code. In this video, we're going to walk through how to create an HTML page using Pycharm. We'll start by checking out a project from version control, adding a new HTML file, putting some content in, and then layering on some structure using HTML elements, that's hypertext markup language. Finally, we'll commit our code and push it back up to GitHub. In the next video, we'll talk about how to make that text look pretty with different colors and fonts and sizes and so forth. Those are all called styles. So here we go. We'll begin by opening Pycharm. So I click it, it will start up and offer me how to open my project. And I want to check one out from version control so that I can save a copy of it later. So I'll open from GitHub. I'm an active GitHub user, so I'll choose the repository I want. Today I'll put this in examples. It asks me, do I want to open that directory? I'll say yes. And here we go. So I will find the directory where I want my code to go. And I'll go up here to the File menu and say New File, and I'll take a new HTML file. And when I do that, I guess it asks me for a name. I will write about hippos, because I like hippos. When I do that, it asks, do I want to start paying attention to this in Git? My answer is yes. And now it gives me a file called hippos.html. I'll make it a little bigger for us all to see. And it has already filled in a bunch of boilerplate, we call this, for me, that has the beginning structure of an HTML document with its head and its body. And I can leave all that in place. It's highlighted here, the title for me, so I will delete that and say my title is Hippos, because I'm excited about hippos. Okay, so let's see, what shall I write here? Well, I'm going to write a poem, so I'm going to start by adding some content. Lots of people have a favorite poem. My favorite poem is about hippos. This is how it goes. I painted my hippos orange and blue. If you had a hippo, wouldn't you too? So that's my page, that's my poem. And now I can go over to here, and just by hovering over here to the right, it brings up this set of options. And these represent the web browsers that are on my machine. So I can choose this one and just click on it, and it will open
Nice.
my page here. And it's all run together. You see that? It just says hippo poem, lots of people have a favorite poem, and so forth. That's exactly, oh my goodness, where did I put it? Here we go. That's exactly this text. But of course, it has not put the line breaks where I put them or put the spacing, because I haven't added any structure to my page yet. I've just put in the content here. So if I want to put in structure, I need to use HTML tags. So I'll put in some tags. I'll start this with the header tag. So H1 says a first level header. And so I bracket hippo poem with my first level header. And now, all of a sudden, it knows to display hippo poem as big and bold and up top. What other structure would I like? Well, this is a paragraph, and it goes all the way up to here. So I'll put a start paragraph tag and an end paragraph tag. And now, it knows that the paragraph has ended, so it goes to the next line. But of course, I want a poem here, so I'll put in a line break. And the curious thing about line breaks is that they are called self-closing tags. I don't need to put a matching close line break here. It's just a standalone one-piece tag. And again, now I've got...
I think I got the point. So what I want to do is try to understand how to increase the size of this thing, that it doesn't seem to be. I want this to take the whole page, obviously. This div here, my network. So I can either change the CSS or try to change the Python script. I think it's gonna be better to change the Python script. Otherwise, every time I create this, I'm gonna have to change it manually. Ideally, the other thing that I wanna do is try to create a way for somehow so I can jump from step to step, line by line, on this graph. Because clearly there's a lot of things. And it seems like I can't. Oh, I can. It's also interesting that these ones don't seem to have a connection with all the other ones. Maybe it's the way that I built the graph on Python. Or maybe it's because they are things that are used in the program, but they don't have a connection to anything else. And the ones in the middle are all from the same workflow, let's say. Yeah, I think that's those that are outside are probably auxiliary functions or things like that. And here it's kind of like the more of the skeleton of the script. If I build it the right way, which I'm not sure that I did. So whenever you have something that calls a function from a package, there's just a configuration or something like that. It's not involved in here. And these are the functions that are directly involved with running the specific script. It would also be cool if I could do somehow a way to open the files when I click this. I have to think about how to do that. The issue here is that I have to understand, I think. Maybe the library they provide this. I'm gonna read the library for the Viz network stuff. But if they don't have the library, I think what I have to do is probably understand how they are creating this dynamically with the Python script so I can put stuff here. Because here I can see that I can change here and then it changes the style somehow. So I guess this is probably used with JavaScript. You can use the get element by ID to run scripts on JavaScript and create functions for the thing, but I'm not really sure how to integrate that with Python. How the integration is done, so it's probably something, definitely something I need to learn. Let me read the documentation. Hopefully they have something here that allows me to do everything that I want. Because I don't want to spend time trying to figure out the JS and CSS part. So I can change the size of the node with size. Size. So maybe I can change the network when I create the object there. It's saying 500 pixels. I have to put it on. on a string. 500 pixels by 500 pixels. Let me remember how I did this as well. So here I think I'm looping through creating a dictionary with zip source zip and the two columns of this data frame that have the function name and function file name. Which brings me another question of how can I use more than two columns to create it? So I think what this is doing, the way that it is done, at least from the documentation there, you add nodes, which create specific nodes, and the edge is the link of those nodes. How are you gonna link them? And I think here it goes from source to this. E is probably probably the value of the dictionary of each one. So I think E is the dictionary with sources and targets. The E0 is going to be sources, and the E1 is going to be targets. So it's creating a node of the function name, a node of the file name. And then it's connecting the two nodes like that. And neighbor data to node hover data. But I'm not sure how it is connecting all the nodes with each other. Maybe it's this thing here. For node in not nodes. Neighbors break plus break dot join neighbor map node ID. If neighbor map node ID. So I think I'm gonna run this just with this thing changed. Just see what happens. Oh, I forgot. I think I'm gonna print E here. Just see what this is. Just see if I'm correct. Then I'm gonna comment this out and see if it changes anything on the graph. And here, oh, I have to close the file, I think. So I might have to run it again. Because I'm overriding I'll probably be overriding the file each time I run. So I think understanding this connection is important. I also have to change the default because it's opening in the Brave browser once it's finished. So I think I'm gonna search that.
Hi, welcome back to our channel again. In this video, we will see how to run automation test on Chrome browser using Selenium and Python. Here we will use Windows Computer and we'll use Pycharm IDE. In the last video, we saw how to install Selenium. To automate Chrome browser, we need to download Chrome driver. We can download Chrome driver from selenium.dev, this website. So this is the official website of selenium.dev. From here, you can download the driver. So here you will find the downloads location. If you don't see downloads location here, please search somewhere on that page. You will find the downloads. Just click
It's
the
not.
downloads and the downloads page will be appeared. And then scroll.
It's not a dictionary, it's a tuple. So, but I think it works. Yeah, it's gonna work pretty much the same way. And edge data is a list of tuples.
Down a little bit and slowly, and you will find this type of section like platforms supported by Selenium.
Oh,
and
I
there is one
forgot
option
to close
browser, another option
this.
operating system. We need to download the driver for our Chrome browser.
So maybe
Okay,
that
so
was
what
the
you have to do,
problem.
we have to expand these browsers, and if we expand, then we'll see there is Chrome. To download Chrome driver, we need to go to this link. So I'm going to access this link by clicking there, and it will come this page. Here you will find all versions available in downloads. Just click there, and all the available versions of Google Chrome will be listed over there. You'll see that there are Google Chrome version 83, 81, 80, somewhere something like that. And for a specific version of browser, we have this type of driver. Okay, so now the question is which versions of driver actually will download. So let's check that. To check the version of your Google Chrome browser, what do you have to do? You have to go to your browser, and then there is a three dot. Just click over there, and then it will pop up this type of menu list. And just go to the help, and under help, when you move your cursor, you'll see about Google Chrome. Just click over there, and it will open a new tab, and it will show you the browser version of Google Chrome. Right now we are seeing 81 version. So for our case, we'll download the driver for 81, and we see this is the 81, and this is the download link of 81 versions of Google Chrome. So I just clicked over there, and it will start the download page. From here, we will see a couple of options like Linux system, Mac system, Windows system. We are using Windows Computer, and definitely we have to choose this one, the Windows 32 version. Okay, just click there, and it will start download the folder and minimize this thing because we don't need it code anywhere in the inside this. We have Selenium project. So if we double click it, and we'll see that this is the project location. Okay, so what we can when we will try to automate the browser charm.py, we can also mention hit enter key of your keyboard, and the file will.
I think it uses the Brave browser because it's my default one, probably. The operational system. The operating system, not operational system. Yeah, now we changed the size of the graph, which is great. So with this changes the size. Now I have to see which one is the much better. Which one is the height one? Which one is the width? Maybe sassier. So this is the code that I used to build that. Oh, so height is the first one. Width is the second. So I'm gonna test a bunch of this. Just see. I think I will play around with this script, just change a bunch of things and see the output, just see to understand what's going on with the nodes. Just trying to see if there's a way to put this on Chrome so it opens on Chrome instead of Brave each time. If I search for change browser settings, web browsers and preview. Nice. Default browser. First listed. Save and change. No, so it's gonna be Chrome here, I guess. System default changes. Custom path. Internet Explorer. First listed is Chrome. So let me apply this. And okay. Here I'm gonna put 100% instead of 1000 pixels and see what happens. Yeah, 100%. So I can change the color as well, which is nice. I think this is gonna be very useful in the future. Because any program I build, I can run through this, and I can see the graphical representation of the scripts and create a visualization model in my mind to remember, to make it easier to remember how it's working. Then maybe I can find a way to create connections with the geometry instead of creating the scripts, and maybe create new stuff with that. I mean, there's a bunch of things that are possible to do, I think. So I think it's really worth spending the time, probably really studying the documentation and then trying to see what things that, okay, so it's still opening on Chrome, on Brave, but Maybe I'll have to reset the browser. So I think 100% width and 100% height is probably the best. So it's on tools, on more browsers and previews. We take Firefox off because I'll show browser. Maybe that's not the configuration I'm looking for. So I think I'm going to really study the documentation of the network graphs and try to see if it contains everything that I want to do. Then if not, I'm going to have to study the CSS and JS, and I'm going to have to think about ways to incorporate the stuff that I want to do. So the first thing that comes to mind is the space. Every time I click space or some other keyboard, other key on the keyboard, it jumps from line to line. Maybe I can use the arrow keys to go back and forth on the script. So yeah, I want to have integration between keyboards, key on the keyboards, and the graph. And I also want to have integration between the graph and the files. So I can open the graph and the file and the script side by side and travel on the graph and on Pycharm simultaneously. I think that would be the best. Because that way I can investigate where it comes from, everything, and how it's connected and related to everything else. And I can see how the functions are. I can create frameworks for designing the functions that I want in my own projects. So another thing that then I'll probably have to think about is how to create a script. I can create scripts that, I'll have to think about scripts that I can think of that will provide good frameworks in graphs so I can explore the structure, let's say, of the workflow of what needs to be created first and how it's going to be connected with other things. So now let me run this. If it doesn't open on Chrome, then I guess I will search a little bit more, but I won't spend too much time on it because it's more worth it to spend time understanding the thing. Yeah, this is much, much better. It just looks so cool. There's something about this that I think is really interesting, but I can't quite put words into what it is. Yeah, it's still opening on Brave. So maybe when I'm changing things, I'm not gonna show it. Just when I think there's something cool or useful. Because what I'm gonna be doing now is just changing this stuff, just see what happens in the graph to understand how these things are created. And then I'll think about the more useful stuff. I'll be right back. Another thing I was thinking about is that there obviously gonna be, for any script, there are gonna be some kinds of files that are fundamental to them, and that probably every script uses, kind of like NumPy or SciPy for machine learning. So it would be good to think about a way to maybe make on the graph different colors for these files, and another color for modules that are specific to certain things. So I can see that the connection of them, because eventually I can use this to build kind of like a skeleton to build my own projects. But then I obviously won't be building the files that are already used for different libraries. So it would be good to know what is the best path to build the files that are not necessarily from other modules, but that I want to build it on my own. And how much of this graph is just files that are already from modules that are common modules, kind of like NumPy and Pandas and other modules like that. So I think here I'm gonna comment this out and see what happens there, if it changes anything. But neighbor data to node over data. Here I'm gonna make more columns. I think I can erase this print statement because I already understand what the tuple is. I'm gonna make a variable for each name there that I have. So func line number is gonna be df. Color file name df color file name color line number is gonna be def. Oh, another thing that I can do is manipulate this data frame on another script to see if I can get any relevant information. Also, it did change a little bit. I guess I'll just copy here and show it every time. So I can see unique values. I think I'm gonna do that right now. CSS manipulation. So now I have to think about, because the way they do it on the tutorial is by adding weights. So I think I can figure out how many unique paths exist. So function file name dot unique, maybe I can print that. Don't remember exactly how to get unique values first from a series. So apparently this shows the unique ones here. So I can think about a way to make the weights as a new column. Add a new column to the data frame called weights, where I just get the frequency of each name. But I have to think about how I'm gonna do that. Because I want every time there's an exact one to add to the weight of that specific thing. Yeah, so it changed to this thing here. The other graph had different sizes for these nodes. Add neighbor data to node hover data. For node in that's not nodes. Maybe I can print net nodes to understand what it is. Oh, neighbor map I have here. Net get adjust list. So neighbor map node ID. Need to understand what is this neighbor map. Neighbor map. And I'm also gonna print that's not nodes. Oops. I think each node is an object and probably has these properties of title value. But I'm not sure how the connection is being made here. Node ID is probably the ID of each node, which is each connection of this, which is the connection between function name and file name. Yeah, so I think each ball of the graph is a function name and file name. And then the lines that connect are the connection between each of them. But it's weird that here has some functions. So here's the path and here are the functions. So it might be slightly different than what I'm thinking about. Yeah, frozen lib bootstrap then has functions from the path. Oh, maybe it's creating a separate one each time. That's why this one has all of them. Because every time it encounters this frozen lib, import lib bootstrap on the data frame, it just makes a new connection like this. Instead of creating a different node for each one. with each one with the each specific frozen lib stuff. So whenever there is already a node, it's gonna only connect that to the node instead of creating two different connections. So let me run again and see what happens there. I need to understand how these connections are being made. So it's creating a node. Why not create only one node with source and dist? List object is not callable. So not nodes is a list. Oh, I'm calling it like a function. Neighbor map is a dictionary. There's a bunch of dictionaries here, but some of them are only. So maybe I need to pretty print this. Get adjusted list. So I think what is happening is this creates a node and the edge creates the connection. So it creates one node with the source, which is the function name, one node with the function file name, and then the edge connects the function name with the file name. But I'm not sure if that's exactly what I want. I'm gonna run it like this. Let me pretty print this. Then I can just change and see what happens when I change each time. My biggest concern is that I'm making a conclusion about what the graph is showing and is not actually what's happening, because that would be obviously really bad. So I really want to make sure that I understand if the connections the graph is showing are the ones that I'm envisioning it showing, which is hard because I'm not sure if I understand the way that I did the data frame here, because it comes from a complex script. So maybe what I need to do is create a simpler script to track at first. That way I can understand it better. And maybe I should separate this from this project as well, now that I'm thinking about it. Because there are a bunch of files here that are kind of useless. for this specific project. So I think what this is doing, the last line there, this line, well, actually here, what these lines are doing are they are increasing the size of the ball of the connection every time there is a new connection made to it. That way, the more connections something has with other things, the bigger the ball gets. So is adding this line to the CSS somehow, I think. I think through this node object, it's changing the title and the value of the node object, which is probably the CSS part. So I think I'm gonna create another project for this. Just so I have a lot less things in this files here. Oh, so here are the files for the C Python. Remember I was starting to figure out where they come from, and I couldn't find it. And the issue that the extension is different. Maybe this is just the explanation of the file, not the file itself. Don't see. It's still interesting anyway. No, here there is the explanation of the functions. I also got the Turing complete thing, which I'm probably gonna be doing at some point. So let me think about the name of the file. Script visualizer. Then I have to see which files that I'm using. So this definer is the main one. I think I can erase this module scalar in here as well. I was gonna use that, but ended up never using it. Now there are other things that I have to think about changing as well, is which objects I'm getting. But I think this is gonna be better to do it later, after I figure out the graphs and the other stuff, because I'm pretty satisfied with what I have so far. At least this one I can stop, trace, num, pd. And here I'm gonna change this. So here, instead of putting module, I'm gonna put file name. I can erase this, erase this. And I can put it here instead. That way each file has a different name. So I'm using this T file there and this network graph only. And the other stuff was for graph these things. So here I think I can also create a folder for data frames and save to this folder so it's more organized. Module finder. Oh yeah, the AI tester as well, which is the script that I was testing. So I think I'm gonna put this here. And define there. And CSV manipulation. So I need to understand what difference the weight makes. Because if this thing is increasing the size of the ball for each connection, then I don't see much of a point of adding the weight there. Yeah, but I think these are all the files. Then probably I will need to install network piece. So let me open this. And I have to think about a more simple script to start. Simple one, but that it isn't so simple that I can't figure out the connections as well. This is their stuff. Here I'm gonna put data frames slash file name. And same thing here. So eventually I'm obviously gonna import the tfinder script here. Maybe, yeah. Maybe I'll have to do the tfinder as a script and not an import file. That way then I'll be able to change the file name when I call it here and put it to this. But now I have to think about a simple Python script. Put it simple here. It's not simple.py, just simple. And here is gonna be simple. Well, the other thing that I just realized is that I have to also change this import name depending. Maybe I can do. I'm not sure if this is possible. So let's see. Import file name. That doesn't work. Doesn't work. But I guess I can just do it manually then. Because every time I wanna run, I'm gonna have to import a different script to run it. Simple not main. So here I'm gonna go main turn a if main equals main. There we go. Just gonna put simple here. So let me think. Probably I wanna do something that involves NumPy. Because I know NumPy is gonna be at least somewhat complex. Maybe I can do something. Let me see. Trying to think about ideas to search for a simple script that is already made because I don't want to do something that is really simple, like adding something or multiplying something. But at the same time, it's not too complex. Pycharm has a built-in web server that can be used to preview and debug your application. This server is always running and does not require any manual configuration. All the project files are served on the built-in server with the root. Press Ctrl+S to open the IDE settings and select Tools, Web Browser. Web browsers and preview page that opens shows the browsers from the predefined list and the previously configured custom browser installations, if any. For each browser, Pycharm shows its name. To activate a browser, select the checkbox next to its name. The browser will be added to the context menu of the Open in Browser menu item, and this icon will be displayed in the browser icons pop-up. The browser was installed according to a standard installation procedure. Most likely, the alias in the path field points at the right location. If it does not, click and select the actual path in the dialog that opens. When you select View Open in Browser, or press Alt F2 or invoke the browser icons bar, the available browsers are shown not in the order in which they are listed in the browsers in preview. Depending on the family of the selected browser, perfect. To launch a browser with Chrome family with additional options, clicking on the toolbar. Tap the required keys in the command line field of the Chrome settings dialog. But that still doesn't solve anything. It's still not opening with the... Maybe I have to put this one so it actually opens. Whatever. So what was I thinking about? Oh, so this is the version of the network that I'm using, which is PyVis. I guess this one is the bigger one that encapsulates all the other different types you can do. Examining elements of a graph. We can examine the nodes and edges. Our basic graph properties facilitated reporting: gnodes, gedges, gadjust, and gdegree. These are set like views of the nodes, edges, neighbors, and degrees of nodes in the graph. They offer a continually updated read-only view into the graph structure. They are also dict-like in that you can look up node and edge data attributes via the views and iterate with data attributes using methods .items.dataspan. If you want a specific container type instead of a view, you can specify one. Here we use lists, though sets, dicts, tuples, and other containers may be better in other contexts. So it's kind of like a list or a dictionary. Oh, they are making it a list with the nodes. One can specify to report the edges and degree from a subset of all nodes using an n bunch. An n bunch is any of none, meaning all nodes. A node are an iterable container of nodes that is not itself a node in the graph. Removing elements from a graph. One can remove nodes and edges from the graph in a similar fashion to adding. Use methods graph.removeNode, graph remove nodes from, remove edge. Using the graph constructors. Graph objects do not have to be built up incrementally. Data specifying graph structure can be passed directly to the constructors of the various graph classes. When creating a graph structure by instantiating one of the graph classes, you can specify data in several formats. So this adds edge 1 and 2 and then creates the graph with those edges. What you use as nodes and edges. You might notice that nodes and edges are not specified as network X objects. This leaves you free to use meaningful items as nodes and edges. The most common choices are numbers or strings, but a node can be any hashable object except none, and an edge can be associated with any object. With any object X using g.addNode, add edge, and one and two. As an example, N1 and N2 could be protein objects from the RCSP protein databank. Next could refer to an XML record of publications, detailing experimental observations of their interaction. I found this power quite useful, but its abuse can lead to surprising behavior unless one is familiar with Python. If in doubt, consider using convert node labels to integers to obtain a more traditional graph with integer labels. So one thing that it just hit me when I was reading this is that probably the best way to navigate through the graph is going to be by creating a script that actually navigates through the data frame. That's probably going to be easier. But then I'm not going to have to figure out how to connect that with the graph properties. But I think I can create something that allows me to go back and forth lines of the data frame, rows of the data frame, and use that row to find the location of the file by using the inspect module. Not just find the location, but open the file on a different tab. So maybe I could also put the index of the thing there. When I'm creating the nodes, I can create something that has the index of each column. So create a number that starts from 0. With the iteration, it increases one by one. But then I have to think about how to attach that information to the node. So I really need to understand what a node object is. Oh, here I forgot to change the name as well. So I'm gonna put file name. Oh, this is not Python maybe, so it might not work. Let's see. So if it's not Python, I think I can use this sign here, or it was something like that. Oh yeah, I was trying to find the script that I'm gonna use. Adding attributes to graphs, nodes, and edges. Attributes such as weight, labels, colors, or whatever Python object you like can be attached to graphs, nodes, and or edges. Yeah, so this label would be really nice. I also have to think if it's gonna be better to attach it on the connection on the edge or on the node itself. Probably the node, because the node is the file. But then it's gonna have to be, yeah, it's gonna have to be for files and not functions, obviously. Yeah, but I'm gonna have to also think about how to navigate on the functions to find the files as well. So how do I map the data frame to the graph? Each graph node and edge can hold key value attribute pairs as in an associated attribute dictionary. The key must be hashable. By default, these are empty, but attributes can be added or changed using add edge, add node, or direct manipulation of the attribute dictionaries named ggraph, gnodes, and gedges for a graph G. Assign graph attributes when creating a new graph. So day plus Friday. Or you can modify attributes later. Add node attributes using add nodes from, or gnodes. Note that adding a node to gnodes does not add it to the graph. Use add node to add new nodes. Similar for edge attributes. Add to change edge attributes using add edges from, or subscript notation. The special attribute weight should be numeric, as it is used by algorithms requiring weighted edges. Directed graphs. The dgraph class provides additional methods and properties specific to the directed graph edges, e.g. digraph out edges, digraph in degree, predecessors, successors, etc. To allow algorithms to work with both classes easily, the directed versions of neighbors is equivalent to successors, while degree imports the sum of in degree and out degree, even though that may feel inconsistent at times. Some algorithms work only for directed graphs, and others are not well defined for directed graphs. Indeed, the tendency to lump directed and indirect graphs together is dangerous. If you want to treat a directed graph as undirected for some measurements, you should probably convert it using direct graph to indirected or with. There are classes for graphs which allows multiple edges between any pair of nodes. This is harder to understand so far than the other one. I wonder how does these people make money through these APIs. They are seeing your data or not. You can close this file, this one as well. So let me think about the script. There's so many things in my mind right now, so this seems really interesting. This seems really, really interesting, actually. God damn. That's crazy. So this is the representation of 10 people on Facebook, I guess. The connections. Is much more useful than the previous one. Already you can glean something about the structure of the network. For example, many of the nodes seem to be highly connected, as we might expect for a social network. We also get a sense that the nodes tend to form clusters. The spring layout serves to give a qualitative, qualitative sense of clustering, but is not designed for repeatable qualitative clustering analysis. We'll revisit evaluating network clustering later in the analysis. Total number of nodes in network 4,000. Total number of nodes of edges 88,000. And the programs are probably the ones on the edges here. Also, the average degree of node can be seen. On average, a node is connected to almost 44 other nodes, also known as neighbors of the node. Nodes connected to almost 44 other nodes, also known as neighbor of the node. This has been calculated by creating a list of all the degrees of the nodes and using numpy.array to find the mean of the created list. There are many interesting properties related to the distribution of paths through the graph. For example, the diameter of a graph represents the longest of the shortest path. Paths that connect any node to another node in the graph. Similarly, the average path length gives a measure of the average number of edges to be traversed to get from one node to another in the network. These attributes can be calculated with the nx.diameter and nx.average shortest path length functions, respectively. Note, however, that these analyses require computing the shortest path between every pair of nodes in the network. It can be quite expensive. Since we're interested in several analyses involving the shortest path, I'm curious about how are they connected again. Each node represents an anonymized Facebook user that belongs to one of those 10 friends lists. So they got friends lists from Facebook. And each node represents one of those people on the friend list. They're very, very interesting ideas in this. I'm probably gonna favorite this, so I'll look at it later. Can you explain a little bit what exactly you're trying to do? Sorry, just got in. Yeah, of course. So you see this? This is let me show you. Do you know Python or not? If you don't know, then I'm gonna explain more. But yeah, so this is pretty much a script that uses something called trace, sys.trace, set trace, which is a module from Python library that allows you to trace a script. So whatever you put here is gonna be a function, and whatever you put on this function is gonna trace whatever comes after this. So it traces frame by frame, which is an execution frame, which is the way that the Python operates, as far as I understand. And I'm kind of new to programming, so it can be, all the things that I'm saying can be wrong. So, but yeah, this creates a set trace, which is gonna trace whatever comes after this, which in my case, I put a script here. Yeah, okay. So I put this script. I wasn't doing with this script, I was doing with this one, which is a script that I'm trying to study. And then it's gonna run this script and it's gonna get this information here from that script, which is the function name, function line, the function file name, and the caller line number, and a bunch of other things. Then from this, it's gonna create this data frame with the information. And then I created, I think it was on this one, yeah, where I'm reading this information and I'm creating a graph from it. And the result is this one. So I'm trying to create something to visualize script execution. And then I plan to expand on that, but I'm not sure exactly what I'm gonna do. So my idea is to create something that I can jump line by line and see the flow of execution of the script, and then eventually figure out which libraries are being used more often, because that way I'm gonna have like a skeleton of like a framework of, because I'm trying to do this to learn how to build my own artificial intelligence library. So I want to understand the flow of execution of all the things are created. So I thought the best way to do that is probably to do this. So that way I can think on my mind when I'm creating the stuff, how the functions are correlated, which libraries are most often used, how are they connected with the other libraries, and I can kind of create a framework in my mind to reproduce these scripts and to create new scripts that are more specific to what I want to do. But obviously, I'm not sure if I'm going to be able to do that, because it seems I have a slight idea of what I'm going to do, but I'm not sure if it's going to be possible with the tools that I have, with the graph and all this stuff. So now I'm thinking about getting a more simple script, because this one is too complex, because I want to understand how the connections are being made. Because this function here from the graph I just took from the tutorial they have on a subsection of this network library that is called pyvis. And I pretty much just copy pasted this, and I'm trying to understand how the nodes are formed and how the edges are formed. Because I want to see if the connection that I'm getting here is the connection that I'm thinking about it. Which link of this? I don't think I can share this because it's on my local computer. Like it's not a website. It's pretty much this file. It's not on here because I created a new project, but the link of the libraries of this library here, pyvis. This is the library for the graphs that I'm using. So I did this one here. What do you mean? This here? This comes from the script that I did here. If you want to reproduce this, it's pretty much, it's not that difficult. You just have to put this sys.setTrace here, then put this function, then you have to create these things here. No, this stuff here I created. These I got from Kaggle, I think. From a Kaggle competition. This one is the one that I copy pasted, which is from the link that I posted there. Yeah, but ideally I want to have something that I can press, like the arrow keys on the keyboard, and I can navigate through the graph, and that is gonna open the files that I'm going through, so I can go back and forth and see what's going on, and I can watch side by side. And I'm also thinking about if I can make it in a way that the most used libraries are done in different colors. So I know that which libraries are more fundamental, let's say, and which ones are created project by project. And then later on, eventually, but that seems really far off, but it might be possible to, instead of creating the script, creating the graph first and making a script that creates the skeleton of whatever I want to do, if that makes sense. But this sounds like really, because I'm not sure if I'm gonna be able to capture the connection with these things, or if there are more things involved. I imagine that it is possible to capture like at least some fundamental aspects of each thing that you're trying to create. But yeah. I mean, there's a bunch of things also that I'm thinking about doing, but it's gonna take a lot of time, and some of them are probably they probably don't make a lot of sense because they're not connected with whatever is possible now with the functions and the libraries we have access to. Thanks for the follow. Imagine, let me see. Yeah, nameless coder. Hmm, thanks. It's really boring though. I have to say, like studying the libraries and stuff. the result is worth it, but the process is not really that flashy, let's say. And there's also a bunch of things that seem really interesting as well, that it might be possible to do. Like this is the documentation from the sites of these graphs, and they are showing this. This is a graph representation of Facebook, with Facebook 10 friends, 10 people, 10 people friends list. The graph representation, and these I can see a lot of applications to this that might be really really interesting. I started a little more than a year ago. I think a year and probably a month now, or maybe close to a month. 1 year and a month. So I'm very new, let's say. JetBrains Academy, what is that? Is a course for programming? What's in your about section? Your about seems really cool, man. I have a lot of stuff here. Uh, how long have you been programming? +20 years. Goddamn. So you definitely understand what I was talking about there with the trace stuff. I don't really feel like I need courses though, to be honest. Like everything I learned so far, I learned for free and by myself. And by doing these projects here, I'm learning a lot. Like I spend a lot of time reading the libraries and researching stuff. Yeah, because I'm only doing this for 1 year, right? So it's not a long time. But it's not like it's not, I don't feel like I'm lost, let's say. Like I can figure out a way to to learn anything that I want. It just takes time. The challenge I have is quite the opposite actually. Is that I have too much stuff. I'm trying to do too many things at once. And then I lose focus. So that's a big problem. Because once you learn something, then there are 10 different things that you can do, and then it goes on forever. Yeah, it's hard though. You probably know everything already. 20 years, man. That's crazy. Yeah, focus one thing, right? Do you have a suggestion of a simple script that I can use to test? I'm trying to think about something that is not going to be super complex, but not super easy. So I can see the interactions of. So I can change stuff here and see what I'm exactly what I'm getting every time I change something. It's okay. I probably research here. I could obviously do it one on my own, but I don't want to think about creating a program, so I'd rather just copy from someone else. Something that's relatively easy. I'm trying to remember if I already did something in the other. Maybe I can get something from other projects. I moved to what's WL? Knowing too many languages help, but you lose focus. But this many is gonna be too difficult. So far, I've learned CSS, JavaScript, HTML, and Python, and then a little bit of C++. But I think I'm gonna stop on this on C probably. I'm gonna learn C++ and then C, and then I'm gonna stop there. And I don't think I'm gonna learn any other language. It's not the best thing to do. Wing language as 5L. Don't have no idea what that is. WinDev. It's probably not what you're talking about. It's probably something related to Windows, obviously. You're doing WinDev, WebDev, and WinDev. First generation remains the machine language or the assembler, very effective to drive a CPU or GPU at the lowest level. The assembler was quickly replaced by so-called procedural languages. Then object-oriented. There is not really definition of these fourth generations for some, including the fourth generation includes language closer to the user, such as Fifth generation languages are much more end user oriented than programmers. Developments are formulated by defining sets of constraints and objectives. There's no doubt that PC Salt has adopted the notion of 5GL to emphasize the easy of development when dev, accessible to everyone. In our opinion, this is not the case, except for really simple applications. Doing WinDev development now is required to have knowledge of relational databases and algorithms. It still doesn't explain windev.com. Yeah. From my understanding so far, the higher the generation is, the higher the level of abstraction, the easier the language is. So Python is easier than C++ because it has a higher level of abstraction. So for me, it makes sense to learn the lower level abstraction ones because it gives me more flexibility. And then it's probably going to be easier to learn the other languages in case I need it. But obviously, then you're going to trade off efficiency sometimes. But I think I'm more of a guy that prefers the flexibility and the speed of execution instead of just making it easier. But that might be because I haven't worked on very big projects yet. Because I imagine that at some points probably gets really confusing and hard to debug. Is this a product or? So it's feature deployed database. An IDE. Oh, interesting. The best to learn would be C++, however, the learning curve is harder. Yeah, from what I've learned so far, it doesn't seem that. I can see why it's harder than Python, but it doesn't seem like impossible. It's just complicated to control. Yeah, the most confusing part for me so far is the pointers stuff. That seems like it's gonna be very confusing to try to apply that in practice. But this is paid, right? Do they have a free version? Don't have a lot of money to buy this. Oh, Express version free. Try version 2, the Express. And this is for all languages? What language do you recommend using this? So far, I'm using Pycharm for Python. Sometimes I use VS Code as well, but not often. And then I was planning on using Visual Studio for C++, because that's what people recommend, but it uses double language. You can implement Net or Java or Python in V27. So it's for Python. In my case. Uses W and language. implement libraries, but Python is not in version 26. Yeah, but if I'm gonna use this, I'm gonna use the latest version anyway. It shouldn't matter that much. But why would you use this instead of using Pycharm? Because there's gonna be the cost of learning a new ID. So I'm not sure if I'm gonna use this. I also have to understand what Stabio language we were talking about. And maybe, and drop it in the, type it in there, the invite. Yeah, it's still interesting though to check it out. No, this is all in French. Spanish. Yeah, that's what I was thinking about. I'm not opposed to trying though. Because you never know, maybe it is worth it. But this is not what I'm looking for. Probably this one. Fifth generation language includes the usual functions of programming languages as well as a native data-oriented platform. The graphic aspects, the check and validation of inputs are performed upstream of coding without standing the editor. The window editor eliminates the coding step of interfaces as it allows for definition and test of interfaces. 100%, I have no idea what it is, mode, including further advanced definition controls. Worth it, however, be prepared for a very different learning curve. It's not Pycharm or nor VS Code. Why do you think it's worth it? Don't forget the WinDev is interfaced with the following languages: Java, C++, C, Hash. Maybe I'll use this instead of Visual Studio for C++ because I haven't really started coding on C++. So I haven't got used to Visual Studio yet. So it might be better to just start with this then. Because I'm gonna have to learn Visual Studio anyway. So instead of learning Visual Studio, I can learn this one and code on C++ on this one. It has nothing to do with any of you know. Do you mean the IDE or the languages? That language reduces the amount of necessary code by up to 90%. Only a small number of functions will be actually used in your application. This list is an exhaustive list. will allow you to never be stuck. The following functions are available. They give the ability to modify the program in what was defined in the editors. It provides additional flexibility. The image found in a file, there's nothing to program. Devs completely standalone IDE and language. Hmm. Hmm. The top of this page, you mean? So it's both an IDE and a language. Cross-platform application development software. Oh. Oh, now I think I understand then. So it's an IDE made for a fifth generation language, which has a higher level of abstraction than the other ones. Yeah, this is 26. Mm. So probably I'll learn C++ first then. C++ and C before I dive into this. But it seems really interesting. And do you know why this was invented? Like, what did they have in mind when they invented this? Holy shit. So you can say it's not that easy. 8 years to control the surface of the bell. God damn. But why use it though? What's the... Do you use other IDs or just this one? It is 10x faster to develop, however, like you said, the learning curve is 10x lower. You can develop... And what about the execution of the code? Like, outside of development time? It's probably slower than the other languages, I imagine, because of the higher level of abstraction. IntelliJ almost always, pretty much for everything. So I think this is probably more useful for bigger projects where you need to think about a lot of different operational systems and platforms. And have a bunch of files. I have no idea. It's probably because of the browser or Google. Because I'm from Brazil, so they put Spanish. But I put language here, English. is LDAO is used in big teams with huge projects. Yeah, I imagine. So that's probably why it was built. But this is really weird because, well, if I research something else, it's probably not gonna be in English. In French. Yeah, this is in English. I have no idea why it's showing this content. If I could go back in time, I would definitely go full C++. What about C? You think C is not worth it? I think, if I'm not mistaken, I heard Elon Musk saying on his Lex Fridman interview that they use C on the self-driving stuff for the artificial intelligence part. But it feels like to me that C is probably going to be really hard because it doesn't have objects, if I understand. It's procedural and not object oriented.
My name is Glenn Rathke and I am from W Expert.
But C++ I'm definitely going to learn for sure.
Dev Mobile Express. Once you've downloaded the product and got it installed,
C and more. But do you think it's worth it, the time invested to learn C, or C++ is already enough for most things?
read the tutorial and then of course...
Because obviously, I'm probably gonna learn C anyways, to be honest, because I want to learn assembly as well. And the compiler stuff.
WinDev. I highly suggest going and reading the concepts. In fact, we'll look at that just quickly here, what's available. These are the different
Learn C at the
concepts
same
that are
time.
available to you within WinDev,
Okay.
so we see how to work with it, as well as you'll notice here's the file.
Yeah, I guess I'll check this out later. I'm gonna have it installed. Probably after I do, after I learn all this other stuff that I have to learn and do the projects that I'm trying to do, then I'll probably look into this. You're never too old, man. It's just a mindset. I'll probably leave it there. I have a lot of things to do, but I'm probably gonna check it out after I do this. I'm not sure how long this is gonna take for me to do everything that I wanna do. Because like I said before, I don't wanna get distracted, that's the problem. Obviously I wanna learn this, but then there's 300,000 things I have to learn through. Yeah, but I'm afraid of not afraid. Well, actually, I like Python as well, but I want to learn more, obviously, because also C++ is faster, and you also learn more about programming in general. Python is more, I feel like it's easy mode, let's say. And then the lower level you go, the more you understand actually what's going on in the computer's mind, let's say. And that's what I'm really interested about. And programming is just the consequence of that, right? yes, it's useful to know the methods of any language, but the fundamentals are more important in my mind. ML don't waste time with WinDev or C. Be perfect in one language, not mediocre. No. Yeah, that makes sense. True. Python plus ML plus AI is the future. What about C++ and AI? Do you think that it's not really worth it, the trade-off of speed? Because it seems like, especially with AI and ML, the bigger the data sets become, the more important the efficiency and the speed is going to become. So at least what I'm thinking right now is C++ and Python is probably going to be, not C++ and Python, C++ and machine learning is going to be what I'm really going to focus on. Way more difficult than Python. Yeah, I know, I have time. I forgot where I put the list of the things that I have to do. I think it was here. Yeah. Yeah, so this is what I'm thinking right now. Like first, I don't have it in this list, but first build this visualization tool, then use this tool to study the ML libraries and try to reconstruct them on my own. After that, deconstruct the libraries, create the libraries in Python using the lower level API of the TensorFlow. Then going back to C++, learning C++, and trying to rebuild everything, but trying to translate what I've built with Python, but in C++. And then after that, create my own stuff and expand on that forever. Pretty much. Oh, I have to think about this script. Let me think about. I'm gonna go to the bathroom right back. So I think I'm gonna use matplotlib or something like that. Shouldn't waste that much time trying to think about the script, should I? Oh, I have to put numpy here some. Maybe I'll just do like this. Okay, so it works. Hopefully this one works as well. Python from scratch? But you don't know Python yet? Do you just know WL? This is extremely interesting for me, these graphs here. Like there is a deep connection between geometry and logic, obviously, because computers are just the connection of wires with electricity that creates a logic that creates information. So I think there's a very deep connection between the geometry of this and the execution of things. That's really, really interesting to me. But I'm not really sure if the level of correlation is correct in thinking this way, because there is abstraction when you're creating scripts. So the name of the functions and the files, well, but it should be correlated somehow. Like there is a correlation between the network of the logic and the problems that it is capable of solving. And I think if we found a correlation, then there could be a way to program using just the information of the geometry instead of the scripts themselves. That makes sense. Like abstract the information of the particular libraries and create the somehow use the graph to solve the problem instead of using the specific libraries, if that makes sense. Yeah, but I think what I'm missing here is the connection of, because this is just the name of the functions and not what they do. So if there was a way to find out, to create a graph of each instruction itself, I think that's probably what I'm gonna try to do next. I think that's probably the right step. Just to get a higher level of accuracy in the description of the connections, and then build infrastructures of logic using the geometrical information instead of trying to figure out how to solve problems by writing the script, because then you're trapped by what you can produce. And if you have the geometrical information, maybe it's possible to create new information out of it. New creative ways to solve problems that you wouldn't have thought about if you were the one designing it from the beginning. I think I started learning by breaking and modifying things. When I started, there were not tutorials. Nowadays, you are lucky, you can learn Python in an hour on YouTube. Yeah, I remember trying to learn programming when I was a kid, and it was definitely a lot harder. I can remember. Like back in the day, there was no videos or anything like that. So I imagine it was exponentially harder. If it even nowadays is kind of hard to find the documentation on libraries and stuff, and then you get stuck. And that's the hardest part. So nowadays, I imagine that back in the day, I imagine that was probably exponentially harder to do anything. See you, man. Have a good time. Have a good run. So did this work? Oh, done. Yeah. Line 31. So probably this data frame is not correct. Oh, it also didn't save. Should put these data frames here. So apparently it worked. No, even this might be too complex. We'll see. So now I just have to figure out. Oh yes, because it's CSV here. Oh no, dripping. This is just the file name and it goes here. So now I have to put data frames here. But yeah, I have to think about if there's a way to get not only the functions but everything else inside the code. And if I remember correctly, when I was doing this, I couldn't get the line here. I think it's this one. Yeah. No, this one. This is. Yeah, this line here. which is supposedly showing every line of code. Interpreter is about to execute a new line of code or re-execute the condition of a loop. Local trace function is called args none. The return value specifies. So maybe it's worth it to, but then the problem is, I think I can do separate projects, one with more specific one and one like this, because the more information I put, the harder it's gonna be to study. So I think this one is probably better to just get a sense of how the libraries work by navigating through the functions and the files. But later on, if I want to try to build something that allows me to create a geographical, not a geographical, but a graphical representation of the connection of logic and how that connection is being used to solve specific problems, then I can do one maybe that has all the lines of code from all the libraries. And then if I'm really ambitious, I can use the C Python as well, not just the Python, to see where they come from and then try to connect everything from the bottom to the top and see what is changing every time they run a different script and what is this script doing. And then potentially build neural networks on top of that to see what is exactly changing and what is not changing within this network. So you can say that the default neural network of the computer is probably the hardware, which is probably similar to humans. Like the ego structure is always consistent, or not always consistent, but it says more consistent than the other parts that are more neuroplastic. And I think that is pretty much the same way that works here, where you have the fundamental bases, which are the hardware and the core libraries that are used every time. And then you have the difference in scripts, depending which task that the thing is trying to solve. And then by figuring out the connection, the graphical connection, I can potentially create some algorithms that study the connection and try to think about new solutions to things. And that line of exploration seems interesting to me. So I think it's probably what I should be doing. So obviously here, there's something wrong with this. So this edge data is probably not working correctly. So what's going on here? The edge data is supposed to give me a list of tuples with function name, function file name. So the file name is this. The function name is just a function. So source should be function name, function file name, function file name. Make file and load. I should delete this for now. Oh, sources. Oops. So let me see. Yeah, find the load, init, enter, path join, get item. So it seems to be correct. The sources. Well, let me see the targets. Yeah, these are the paths. Yeah, so this one is slightly less complex because it only has 140,000 lines. The other one had 170,000, I guess. But I don't understand why this is not zipping as the other one. Maybe I'll have to open the other project and a new window just to see. Oh, now it's working. So maybe I just typed something wrong there. Zip object at this. So now let me print this. Yeah, seems to be working now. So maybe it was the print statements there or something that I did. Well, hopefully now it will save. Oh, error. So it's something on the lines that is probably. Line 33. Yeah, when it's creating a node, some of the nodes is instance and ID string or instance and ID int. Maybe I can use a try except block there to solve this. So for some reason, some row of one of the columns is not a string or int. So I'm gonna put function name here. It's lagging a bit because of this stuff. Dot d types. I think it was like this to find out which type it is. Here's like this then. Yeah, object. So it's a string. So now I have to think about what is possibly causing that. Or maybe it's just Gen X. Yeah, it's probably this. Because of this symbol here. It's probably something to do with the way that the node is created. And the language. Yeah, because that's the only thing that's probably different between the Python. Yeah, I'm gonna use a try except block and then I'm gonna print the E0 and E1 and see what happens. I'm gonna print E. Well, here is gonna be conflicting, so I'm gonna put with F. And then I'm gonna print E0 and E1. My guess is that is the generator stuff. So I have two options. Either I can do a regedit or regex thing to clean the column, to erase that somehow, those symbols. Yeah, now it worked, but it's printing then. Maybe if I print is no here, dot sum. So 0 nulls on this one. Also, there's one null value on the function name. That's the problem. So maybe I need to erase that before I run this network graph stuff. So maybe I can do df drop in a. Let me see. So I'm gonna print this and then I'm gonna do df equals df and see if it changes anything. So still 1. So I'm probably gonna have to research that as well. And I don't think this helped much because this is probably even more complex than the other one. And I think I'm gonna have to research how to. Oh, maybe I can put access here. Equals 0. It doesn't solve anything. Got it. So I'll probably have to research how to drop no values from the columns again. Because I forgot. Maybe I'll have to drop by each column, but then it's gonna be a lot of. Oh, I'm printing the wrong thing. That's why. It's probably working. No, but now it's printing the whole thing. There's no. Oh no, it worked. So here's 1, and now it's 0. So I'll probably do this here. And that should work then. But I think it's still useful to leave on the try except block because there's no reason not to. Yeah. This looks even more difficult than the other one. True. This is insane. So maybe I can try to do an even more simple one or just accept this thing here. I think I'm gonna test with a very simple one and see what happens. Like I'm gonna do one without any libraries and any stuff like that. Just some simple multiplications and see what happens. And I probably should write down what I need to do because I'm probably gonna forget what I want to do actually. Because I already forgot which steps was supposed to do now. Just let me play around with the graph. Yeah, I'm not gonna. I'm probably just gonna focus on this stuff and what I have to do, and then any other new things I'm gonna put on the bottom of the list of the things that I wanna do. I also have to put solidity there because I need to study solidity as well. So the only things that I'm gonna add here that are not on this list are things that come up and that might be necessary to do whatever I'm doing on the specific step. So these ones I can put here because it's a necessary part. Yeah, so actually I'm not even gonna do these numbers because I'm probably gonna add a bunch of stuff here. Now this open office thing is an I. to study solidity. Explore or study window. Then here, let me think about what do I want to do. So I think first I'm gonna play around with this thing. I'm gonna try to do a bunch of variations so I understand the nodes. Then I can see CSV manipulation. Try to build a new column with weights for frequency of files, which I'm not sure if it's going to be necessary or not. Because I think this graph is already doing this with the size of the ball. The bigger the size, the more connections it has. Now the thing that I'm not sure about is which thing I'm gonna do first, because I also want to do the more complex graph as well. Not just with functions, but with each line of code. And that's probably gonna take a long time, because I'm not sure if it's gonna be possible to do that only with the set trace stuff. And if it's not possible to do with the set trace, then it's probably gonna take me a lot of days, if not months, to understand how the execution of Python works. Because so far with the stuff that I know, I don't know very well how Python works on the background with the C Python and stuff, which I probably have to study anyway. But yeah, so I think that might be better for later, because after I study C++, then it's already gonna be related. So new column for the weights, then I figure out how to connect the graph with the data frame. So I can travel along the graph and the data frame at the same time. So ideally with the arrow keys, I'm gonna figure out a way that I can jump through these balls here and keep track of which part I am on the data frame. So I'm not really sure how to put that. Maybe, yeah, because I would probably have to understand how these objects work and how they're integrated with the HTML. So yeah, we'll have to study the library first, I think. Travel along the graph. Oh. But I'm not sure if that's gonna take too long, actually. Might be a waste of time to try to figure out how the library works. Now, how to connect Python scripts with the graph. library. A custom Python script, let's say. It should probably be possible because they built it on Python, so it's definitely possible. Just a matter of time. But I think it might be worth it because if I can create custom Python scripts to play around with the graph, then obviously that gives me a lot more flexibility on what I can do. In dev, you already have too much on the plate. Yeah, but I can leave it here and just do it later, right? Because, I mean, the learning never stops. So it's always good to have more things to do, I guess. It's possible to learn and know all that. Yeah. The thing is, I'm not putting timestamps here. So even this step that I'm on right now can take me a year. Like, it's not necessarily that I'm gonna study all this stuff. It's more like a list of things that I can organize myself on in the direction of the things that I'm trying to do. That makes sense. But even this thing can take me to another thing that ends up getting me to another stuff, and then, yeah. If you're from Brazil, then you can check the videos of Amarildo Matos on YouTube. Who is this? Who is this guy? Is a programmer? Like, what is this related to? I'm gonna search here. Oh, it's about the WinDev stuff. I'm gonna subscribe to him. I can already also put his name here. But I think the main thing that I'm doing and that I'll probably do is this stuff here. I think that's my main focus. And the rest is just like the cherry on top, let's say. But I think essentially that's probably the way. I'm not sure if it's possible to solve any problem with this, but at least in my mind right now, that's what makes sense. It's just because logic is connection between points, and information is the structure of that connection. And that's how we solve problems. So there's obviously data as well, and that's what a neural network is. It's just a bunch of connections trying to fit to the data. So it's all about figuring out the geometry of the logic and understanding how it moves through time. So obviously expanding on that, but then that's probably really later because that's going to be probably extremely hard, which is to add physical principles into this, to put like connectivity, like electricity, space-time, gravity, all this stuff. Because it's not only about the connections, but the frequency of exposure, let's say, which involves all the other physical concepts and principles of density and relativity and tensors and stuff like that. Which is probably gonna take me, if it's even possible, but several years probably to understand. Okay, so study network graphs, build a bunch of variations. Then add the weight columns, figure out how to connect the graph with the data frame so it can travel along the graph, data frame at the same time. Using key arrows. So what was the other thing that I was thinking about? Oh, figure out, maybe before I even do that, figure out how to make different colors based on frequency. And try to find a way to extract the fundamental frameworks of most scripts. Yeah, so I think a good way to expand on that's probably going to be to do something that takes the variety of graphs from all these scripts and then abstracts that. But then maybe I can do that with data frame as well. I don't need the graphs necessarily. Unless there is connection between the scripts that I'm going to run. But I can just do a bunch of graphs and then figure out which libraries are being used. Just try to create a framework that abstracts all the main components into a structure. But I'm not really sure as well if that's really necessary or not. I think the graphs are more for the visual aspect and to make sense of, but it's probably not necessary. It's probably possible to do only with the data frames. But I still think it will be cool to visualize, so definitely gonna do the graphs as well. Because it's easier to think about it when you see the graph. So figure out how to make colors based on frequency. So I could build a bunch of scripts, then take the fundamental libraries, make a different color for them, then create a bunch of other structures and see if I can highlight that. Yeah, how to highlight. Specific nodes. Yeah, then there's more stuff that I'm thinking about, but that's probably gonna be better to put after this stuff here. Figure out how to connect the graph with the data frame so I can travel along the graph and data frame at the same time. Figure out how to make so how to attach a keyword in order to open the file of the current highlighted node. So I can open the files as I explore this stuff. And the thing is, on these graphs, the only physical relevance, let's say, is the connection, which is the size of this node. And yes, pretty much the connection and the nodes. So there isn't obvious way to, because I can move these nodes around, but yeah, there is a core fundamental principle to the structure because of the way that the connection is formed, which means that the graph is going to be like this. But there isn't necessarily an overall shape, let's say. But I'm trying to think about it if there is a way to try to use the graphs then, like after I have the graph, instead of using the information or the graph, abstract the graph from the information and get the connections instead. And see if I can kind of reverse engineer the process. Yeah, but it sounds like it's gonna be extremely difficult, but it is something that I think is worth trying to do. I'm not sure if it's worth it before I explore the library or after. That's the problem though. I'm gonna put it here, and then if it's too difficult, I'm gonna pass it. I'm gonna study the TensorFlow library first. To attach a keyword in order to open the file, the current highlighter node. So try to understand if they're to abstract or separate the graph from the information that was built. Just get the node structure. Nodes and edges. Because the other thing, yeah, that's probably the other thing that I'm forgetting about is that this is the simple graph. In order to do what I really want to do, I would have to get line by line and not just the functions. Because if I get just the functions, I'm going to lose the abstraction. If I don't have all the set of instructions, then the geometrical representation of the connection is not going to be accurate. So to understand the flow of information, I need to increase the clarity, let's say the amount of lines of code of the direct instructions that I'm getting. Because then I'm not really sure as well. Yeah, it's kind of hard to think about how the instructions are going to translate into the solution, but they obviously do. Otherwise, it wouldn't work. So there's no reason why it shouldn't be possible to use the graphical structure of the connections to solve the problem without having the use the graphical instructions to find the solution. It's kind of like doing a neural network in a way. What I'm trying to do. Because I'm just getting the node. Yeah, the only difference is gonna be that then these nodes are gonna be broke down into more nodes that represent a higher level of connection. And that somehow solves the problem. So there's also the flow that is important as well. Just forgetting about that. So before I do all of this, I need to build the representation of the flow of information. Because not only the connection is that's the thing that I was missing. Is where the first instructions come from. So maybe I can do an animation as well, where I can run this. Yeah, that would be cool as well, I think. I can run the script and then it shows like the travel path of the thing. Yeah, that sounds really interesting. It's kind of like a neuron firing off. And the connections represent the mass. How big the strength is. Hmm. Study if it's possible. Build an animation that shows travel path. I'll probably have to break down into several different topics this one because it's gonna involve building. I'm not sure if if the best way to do it this is gonna be when the graph is being built. Probably not. Yeah, so probably this has to come after the custom script stuff. Because first I will have to figure out how to create things that allow me to manipulate the graph outside of building. Yeah, I'll have to understand how to manipulate the nodes and the edges. But not only that, to understand how to not change them, but yeah, probably change them because I will highlight them. Can highlight the nodes by giving them properties, probably. If I can change them in the color and stuff like that. Oh, I already figured out how to connect the graph with the different. Oh no, this is other stuff. So I'll probably put it here. Yeah, and I think this is enough for now. So I have a direction to go. It's probably gonna take me a bunch of time, but that's fine. And it's probably gonna be hard. So I have to read the documentation a lot. And let me see. So the first thing that I think I'm gonna do is put the line here. Also have to see how to create different types of representations, because this is representing the description outside the node. So I have to see if that I can do it inside the node. But I think first I'm gonna try to add one more thing here and see what happens, because I'm curious about it. Which one? So color file name seems the most interesting. So not sure if this is gonna work. Seems like I can do an edge with 3. I'm probably gonna watch videos on that. Maybe continue reading this documentation here to understand how it works more. This is the license. What time it is? Oh, it's already late. So I'm probably gonna go work out now and come back later. See. Yeah, I'm gonna take a break, go work out. And when I come back, I'm gonna probably watch these videos and then study the documentation, so I understand more what exactly is going on here when I build these edges and when I build the nodes. And then probably create a bunch of different graphs, just see what happens with the information on the data frame. So yeah, I'll be back probably soon. See ya.